here to present our Group 2 Assignment 2 project. I'm Veasna Kuoy and will guide you through our code and the contribution of each team member. Let's begin with our presentation. Step 1. Data loading and descriptive statistics. In step 1, I focus on data loading and providing descriptive statistics. I used the Panda library to load the data from the file and created a summary of descriptive statistics for each feature in the dataset. This allows us to gain an overview of the data central tendency, spread, and other statistical measures. Now that my step is complete, let's move on to the next step.
Now let's dive into the heart of our analysis, which is hypothesis testing. Our goal was to uncover significant differences between two distinct groups, individuals with Parkinson's disease (PD) and those without. To tackle this, we opted for the t-statistic, a potential tool when comparing means in large datasets. Imagine a vast dataset with numerous features, each representing a unique aspect of these individuals' vocal characteristics. Our approach was to systematically evaluate these features, searching for substantial disparities between the two groups. To achieve this, we employed a loop to run t-tests across all relevant features. And as we embarked on this approach, we realized the significance of each feature might not be immediately apparent. Hence, we calculated p-values, a quantifiable measure of evidence supporting or refuting our hypotheses. With our predefined significance level, alpha set at 0.05, any p-value below this threshold indicated a noteworthy difference. In essence, features with p-values below 0.05 became our focal points. They offered a compelling narrative of pronounced differences in vocal characteristics between PD and non-PD patients. However, we're conscious of the limitations posed by the enormity of our datasets. This volume can introduce noise and potentially lead to inaccurate results. After hypothesis testing, we also visualize the results using box plots in which David will now explain.
Despite this limitation, the significance of our finding is underscored by the external support we gathered. Through research, we found validation in an established journal. This cross-referencing added a layer of credibility to our result. To provide a visual representation of the significant difference, we employed box plots, which is shown as in here. This plot vividly displayed the median of these silent features for both PD and non-PD group. The separation of median emphasized the magnitude of this difference. Features like 0% touch, which predominantly appear in PD patients, are clear example of the compelling story this box plot tells. Our hypothesis testing approach took us through a web of features, p-value, and external validation. It's true that the scale of our dataset poses limitation, but our critical thinking and reliance on established research reinforce our narrative. This box plot added a visual dimension to our finding, captured the essence of the difference in vocal characteristics. Besides using box plots, we also can visualize the data frame using various other methods such as scatterplot, correlation heat map, and more to comprehensively understanding the data. In this particular scenario, we are opting for histogram to represent the data distribution, which can be generated from this code. Just one. This can be achieved through a Python library such as known as Seaborn library. This approach generates a histogram figure illustrating a J-shaped distribution. Such distributions are commonly observed in health-related dataset where a majority of the individuals are either healthy or experience a mild symptom, while a smaller proportion experience more severe condition. A histogram is observed through the X and Y axis. In this case, the x-axis represents the Unified Parkinson Disease Rating Scale, consisting of 20 range. The y-axis represents the frequency at which data points fall within this range. The J-shaped histogram signifies that a majority of patients experience a mild symptom, evidently from the elongated tail of the J-shape. This followed by a smaller number of severe cases, indicating that only a minority of patients score higher on the UPDRS scale, implying severe symptoms. Understanding this pattern provides researchers with valuable insight into the range of symptoms within the study population. It is also important to note that while histogram provides an initial impression of the data, it has its limitation. Additional analyses are necessary to understand the underlying factors contributing to this distribution fully. Now moving on to the first step, which is data wrangling, will be handled by Chloe.
Your data wrangling process is carried out using the depth function, which is responsible for creating a filter data set that includes only the features we need. We create a new data set named the filter data, which includes the specific features that we've determined are relevant for our analysis. Once we have our filter data set, the depth member for function saves it as a CSV file. This file is saved at a specific file path on our system. So the toCSV method is used to save the filter data to a CS file. The index false parameter ensures that the index column is not saved to the file. Now we're trying to perform data wrangling. So we can see successfully perform data wrangling in here. So the main function is the entry point of our code, and it orchestrates the entire process. In the main function, we specify the file path to the filter data that we saved earlier. Then we use the load data function to load this filter data into memory for further analysis. To summarize, data wrangling is a critical step that helps us prepare and organize our data for analysis. By selecting relevant features and creating the filter data set, we can reduce noise and focus on what's important. The depth function plays a key role in this process by creating and saving the filter data set, and the main function ensures the execution of the entire workflow. In conclusion, our team collaborated to tackle different aspects of the assignment, from loading and summarizing data to hypothesis testing, visualization, and data wrangling. Our code demonstrates effective teamwork and a comprehensive approach to analyzing the dataset. Thank you.